Hi everyone, welcome back. So this is still the organic chemistry alkane part, where we left off from the last question. We still have a few more structures to name using the IUPAC nomenclature. Let's start now with this one. Okay, so there's going to be quite a bit redrawing here because they use this parenthesis type of structure. So let's redraw it. 2CH3 CH2. Okay, that's one of the three substituents on the CH group. So here we come, CH, and here comes another one of the CH2C thing. Okay, and at the end, CH2CH3, and we have yet another one of those three to draw. This one above the basic structure. It's CH2, C, 2 methyls, CH2, CH3. Right? Okay, hope this all makes sense to you. So now let's pick the main chain for this. It's actually not that hard because it's simply gonna be this long chain here. Okay, it could be this one here too, but it will be the same, no difference. Same main chain, same substituents, right? So stay with this main chain. How many carbons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 carbons, so it's gonna be a undecane. Right? And the substituents are gonna be 4 methyl groups. Okay, and another substituent that's kind of big and bulky there. So 5 substituents, we figured out. The numbering for the main chain goes either way, doesn't matter, because it's really kind of symmetrical, the molecule. So let's start with from the left hand side and go 1, 2, 3. So these 2 methyl are on the 3rd carbon, 4, 5, 6, 7, 8, 9. These other 2 methyl groups are on the 9th carbon. Alright, and this group here is on the 3, 4, 5, 6 carbon. Now the question is, how do we name this group here? Right? Because these we know it's called methyl. But this substituent here, we don't have a name readily available for it. It's not methyl, it's not ethyl or propyl or butyl or anything. So we have to just go ahead and name this as if we name a alkane molecule. Okay, so we have to pick the main chain, which is, well, simply this chain here, a 5 carbon chain. So it's pentyl. It could be pentane, but because it's a substituent, we call it pento. It's a substituted pento. So where are the substituents? Let's use a different color right here. Substituents are these two methyl groups. Okay, it's getting quite busy. I'm sorry about that, but hopefully makes some sense for you. So it's two methyl groups. What about the numbering within this group? Not the numbering for this entire alkane molecule, but the numbering within this substituent group. So we have 5 carbons, right? Numbering goes from the carbon that's connected to the main chain. Alright, so this will be number 1, 1, 2, 3, 4, 5. So both methyl groups are on the 3rd carbon in this substituent. So this substituent, this big substituent, we call 3 dimethyl. Pento. Okay, so it's this entire substituent is named 3,3-dimethyl pento because it's got a main chain by itself, which is a pento chain. It's a it could be a pentane, but it's pento because it's a substituent, not a molecule. And it's got 2 substituents on itself, 2 methyl groups on the 3rd carbon. 3rd carbon because carbon number 1 is this carbon that's attached to the main chain, and we go 1, 2, 3. 3, 3, 2 methyl groups. Dimethyl pento. That's the name for the substituent. Alright. So 4 methyl groups, one of these groups, and then it's pretty straightforward. So it's 3, 3, 9, 9 tetramethyl. Right? Remember how we call those same substituents? We use prefix such as tri or tetra. Tetra meaning there are 4 of them. Tetramethyl hyphen 6, because this group is on the 6th carbon on the main chain. 6 parenthesis 3,3-dimethyl pento. We put this whole thing in a parenthesis. Sorry, I'm running out of space. But it's gonna be undecane. This is one word, right? No space, no hyphen, nothing. Just because I ran out of space, I have to put undecane in this next row here. So tetramethyl, and the 5th substituent, which is this guy in this parenthesis, we put it in a parenthesis because we had to name this substituent before we called it in the entire nomenclature. Okay? Hope it makes sense to you. Alright, next one. Alright, now this one appears to be much more straightforward than the last one. So, but we still have to redraw it. I prefer white for this one. So CH3, so 4 same ethyl groups connected to the same carbon. So that's one of them. That's that carbon. That's another CH2, CH3. Here comes the 3rd one. And here's the last one. Okay, that's it. So the main chain would be just this 5 carbon chain, which is a pentane. pentane. And the substituents are here and here. The numbering is that both are on the third carbon, whichever way you choose to start the numbering from. So the name would be simply 3, 2 ethyl groups, so it's diethyl pentane. 3,3-diethyl pentane. That's it. Okay, the next one. Okay, as always, let's draw the full structure first. Change color real quick. Okay. CH3, CH2. That's one of the two groups on this CH group. And that's the other one. Okay, and then another CH with the methyl connected to it, and then CH2, CH3. Okay, so now the main chain is, again, obviously this one, the 6 carbon chain, right? So it's a hexane, and the substituents are right here and right here. So what about the numbering? Now this is another example where the numbering is decided by the alphabetical order, actually. So because ethyl has higher alphabetical order than methyl, so ethyl gets to keep the lowest number. So that's why we have to start the numbering from left hand side and go 1, 2, 3 for the ethyl and 4 for the methyl, instead of the other way around, right? Because this way the alphabetically more priority group has the lowest number. Okay, now it's pretty clear. It's ethyl on the 3rd carbon, so 3 ethyl. Remember, because it's got highest priority alphabetically, not only does it have the lowest number, but it appears in the front in the name as well, right? So we start with this one, 3 ethyl, 4 methyl, hexane. Did you follow me? Very nice. Next one now. Now the last one for today. We're almost there. Actually, this one, structure-wise, is pretty similar to the last one we did. I think it's got just one extra methyl group. But we will see that the numbering for the main chain is the opposite, I think, compared to the last one. I'll show you how. But first, again, let's redraw it into the full structure. Do we have the, okay, we do have the right color, but 1 second. Okay, so it's CH3, CH2, one of the two attached to this CH, and here is the other one attached to the same CH. Actually, let's draw that methyl group on the top to avoid running out of space for the other groups. Okay, 2 ethyl groups attached to the CH, followed by a C bearing 2 methyl groups. Okay, from now on, just same thing. Okay, so again, the main chain is really easy. This guy here. But when it comes to the numbering, it's a little interesting because it's not alphabetical this time. We don't yet have to compare the alphabetical order because there's a third substituent there. Okay, we have 3 substituents, 1 ethyl and 2 methyl. So which side do we start for the numbering of the main chain? It's determined by the third branch, because first of all, whichever side we start, there is always going to be a substituent that will have a lowest possible number. In both cases, it's carbon number 3. So we have to, before we compare the alphabetical, there's another rule that says if there's a third branch, if there's a third substituent, the end that's closest to the third substituent is where the numbering begins. So in this case, we're beginning from this side, go 1, 2, rather than 1, 2, 3 like that. Okay, did you follow me? If there are 2 groups with equal distance to the chain end, then we have to look at the third group, if there is one, before we ever go to the alphabetical order comparison stage. Before that, there's another rule that says whichever end that's closer to the third substituent is the end where the numbering begins. Okay, so in this case, numbering will begin from this end, which is closer to this third substituent than this end is. So the numbering for these substituents is carbon number 3 for this methyl and this methyl, and number 4 for this ethyl, right? And 5, 6 like that. Okay, so that's that. Let me change color. Again, I forgot. The main chain is gonna be a hexane. So with that and the substituent and the numbering, we got 4 ethyl, right? Ethyl group on the 4th carbon. We put it first because alphabetically. Oops, I was not thinking. As I was talking, I sometimes tend to make mistakes like that. 4 ethyl, 2 methyl groups on the same carbon, carbon number 3. So 3, 3, dimethyl, hexane. So again, ethyl goes in front of methyl because of alphabetical order, but alphabetical order here in this case has nothing to do with the numbering. Numbering is determined using the third substituent rule. It has nothing to do with the alphabetical order, but the alphabetical order does determine which one of these 2 substituent is written in front of the other one. Okay. Alright, so congratulations. By now I think you are probably an expert in nomenclature of alkanes. Okay, so please subscribe to my channel, or again go to MacroLearning.com, and any questions you have, or any comments or doubts you have regarding my problems and examples and solutions, please just email me or call me. Alright, thank you so much, and see you next time.